And we're back for part 2. Okay, so I'm just going to continue where I left off. So if the base is e, and they don't write the base of e normally, they just write, you know how like when I was just telling you if you're going to write the log of something, they assume the base is 10. When you're writing the natural log, you're assuming the base is e. So, but I wrote it for you. And this shows you, when you rewrite it as an exponential, e squared. So e squared should equal x plus 1 quantity squared. All right, now we've got to solve for that x. So I'm going to take the square root of both sides. And in doing so, the square root of e squared is actually the absolute value of e, which ends up making e plus or minus. So plus or minus e equals, and then square root of x plus 1 squared is just x plus 1. Now, we have to solve for x. We're not quite done, so we move the 1 over to the other side. And when we do that, it's a negative. So it's negative 1 plus or minus e equals x. Those are two solutions. One of the solutions is x equals negative 1 plus e, and the other one is x equals negative 1 minus e. And e is 2.7. So what you need to do is you need to throw in those numbers. So approximately 1.7, because negative 1 plus 2.7, and then approximately negative, what is it, 3.7, and just make sure that those values work over here. And it turns out that this one is very, very negative, and that's not going to work. So the only solution we've got looks like this one. Example 5. Okay, so they're asking you to use the change of base formula, which you're not going to use very often, but it's nice to have it kind of in your toolbox. So if I rewrite this base of 9 as a 3, okay, so if I write the log base 3 of x equals log base 3 of 2x plus 3 over log base 3 of the original base, 9. That's an actual number, right? Because 3 to the what power equals 9. We know that's going to be squared. So I'm just going to rewrite this as log base 3 of x equals log base 3 of 2x plus 3 over 2. Because log base 3 of 9 equals 2. So now I'm just going to think of this as, you know, a proportion, cross multiply. I mean, or you can multiply, you could think about multiplying both sides by 2. It is the same thing. However you want to think about it. The 2 is going to go with the log of x. So it's 2 log base 3 of x equals log base 3 of 2x plus 3. We're getting somewhere. We are getting somewhere. This is amazing. Okay, now, if we can just get log base 3 of some stuff equals log base 3 of some stuff, we can set that some stuff, those exponents equal, and then we can get rid of the logs. So let's do it. Let's move that 2 that's in front using those log properties as an exponent. When I do that, and I'm running out of room, so I'm going to rewrite up here, log base 3 of x squared equals log base 3 of 2x plus 3. Okay, so now I've got x squared equals 2x plus 3, and then I shove everything to the same side. X squared minus 2x minus 3 equals 0. Factor, and I end up getting what? X minus 3, x plus 1. Does that work? Outer is 1, inner is negative 2. Perfect. Okay, so x should equal 3 and x should equal negative 1. Let's see if those work. Now, when we check to see if they work, we've got to plug them back into the original equation. And I can already tell there's no way I'm plugging in a negative 1 because it's log base 3 of negative 1. Done. So here's your answer. This is it's tricky, but if you know your log properties, it's really just algebraic manipulation, and it's kind of fun, gotta admit. I know you guys are probably like rolling your eyes at the word fun, but okay, now we're going to use U-substitution again. which we learned in, was it the last unit? Factoring an exponential equation. So you've got a trinomial with some just funky numbers. And we know that 2 to the x times 2 to the x equals 2 to the 2x, because whenever you have the same base, you're adding the exponents, right? So since I know that about the first term, I'm going to go ahead and I'm going to use y instead of u. Let y equal 2 to the x, because now I can rewrite this as y squared minus 12y plus 32 equals 0. And then I can factor. This is a nice one. Y minus 4, y minus 8. So y equals 4 and y equals 8. Now, we're not done because the original problem has a 2 to the x, not a y. So we'll just go ahead and substitute the 2 to the x back in for the y. So 2 to the x equals 4 and 2 to the x equals 8. Let's see what we got. That should be x is 2 and x is 3. Fun. All right, try B, press pause and try B. So here's B. If I use n, let n equal 5 to the x and rewrote the equation with n and then factored it and then wrote n equals negative 25, n equals 5, and then substituted back in the 5 to the x for n, I'm going to see right away this is not going to give me a solution. So the only solution that I'm going to have that's going to work is x equals 1. We are almost done. Do not worry. All right, I believe this is the last problem. And it's just more manipulation. So if I go ahead and start and, I'm solving for e to the x here, 2 times 3, and I get a 6. The first thing I notice is e to the negative x is the same thing as 1 over e to the x. Well, in this other term, I've got an e to the x, and now I've got an e to the x in the denominator. So I don't want to deal with any of that. I'm just going to multiply through the entire equation, both sides, by e to the x. That way, e to the x times e to the x is e to the x squared. And then when I multiply e to the x times e to the negative x, that just ends up being a 1. Because think about it. If you've got 1 over e to the x and you're multiplying by e to the x, it's just e to the x over e to the x. So it's just 1. And then I also have to multiply the 6 by e to the x. So now, if I use U-substitution, in this case I'm using instead of U, M, okay? I'm just trying to show you. You can use whatever letter you want, Let e to the x equal m, throw the m's in, move this to the other side, right? Get my trinomial, try to factor it. Crap, I can't factor. Okay, this does sometimes happen. If you can't factor, then usually you go to quadratic formula. And that's negative b equals, negative b plus or minus b squared minus 4ac over 2a. And you should probably just have that memorized because it's super useful and you'll end up using it. So remember the quadratic formula. Obviously, you won't have to know it for a test or anything because you can always look it up, but just it's a really good idea to have that memorized. And making sure that anytime you square b, whatever b is, positive or negative, it's going to end up being a positive value there, because negative times a negative is also a positive. So if you do your order of operations right, you should get 3 plus or minus the square root of 10. So now we are using m substitution, right? So I'm going to throw the e to the x back in for my m. And this is 2 solutions. This is 3 plus the square root of 10 and 3 minus the square root of 10. 3 minus the square root of 10 I know is going to be negative because the square root of 10 is bigger than the square root of 9. And the square root of 9 is 3. So if I'm subtracting a number that's bigger than 3, I'm going to get a negative value. Done, not a solution. Okay. However, my last step here, since I'm solving for x, I need to rewrite this exponential term as a logarithm. So if I write if I rewrite this as a logarithmic function, so log base e, so it's natural log base e of natural log base e of 3 plus root 10 equals x. I've got it isolated and we're done. And that's your answer. I mean, you can leave it just like that. That's it. Peace out. Sorry the videos are so long today.